Welcome to Q4Quantum, a monologue where I explain how quantum is becoming useful and practical and relevant to industry. My name is Sridhar and I'm happy to have you guys join me today for another interesting monologue from the world of quantum. So the quantum article which we're going to discuss today is how Quemix and Honda in Japan are working together to accelerate the density functional theory calculation. So density functional theory calculations are nothing but they are the foundation methods in computational material science experiments. Now, Quemix has got investments from Honda where they're utilizing these investments to enhance the value of its product and services and realize the quantum computer deployment in real world use cases. Through this effort, what we see is Quemix is trying to make sure they accelerate the development of new battery materials and new other materials as well. The two most important points from this collaboration is Quemix is not using Gram-Schmidt orthogonalization processes, but rather they are using quantum phase estimation algorithm in order to estimate or calculate the total energy information state of the system. And the second most important point is currently they're running all these experiments on an emulator rather than running it on an FTQ's quantum processor right now. Now, what does it technically mean? As we know, Quemix is accelerating the development of DFT-based calculations, but with the old classical DFT computational method approach, if they go by that, they would be estimating the electron structure and the material properties. So what happens here is the basic workflow goes like this. First, a material structure is given to the system, and then energy state of the system is calculated, total properties of the system being calculated, and then it goes to the material evaluation. So the system goes from providing material structure to material evaluation happening. And this is very much computationally expensive. Reason, once the system or the material size increases or becomes more complex, the DFT calculation becomes very much expensive as well. That's why they are using QPE for energy state measurement in order to cut down the cost of expensive DFT calculations. Now, why is it important? For Honda, it's very obvious they want to design lightweight vehicle materials, battery systems, and these simulations are very relevant to semiconductors, lightweight alloys, batteries, catalyst, and magnetic materials. Who should be listening to this monologue? So the topic is very much relevant for automotive R&D organizations, battery material companies, material science researchers, and most importantly, CTOs evaluating quantum simulations. Now, what value will this create for businesses? So enterprises working in the material sector, what they can see is the benefit for them would be larger material simulation systems can be computationally accessible, more candid materials can be screened by them, and material development cycle will also be shortened for them as well. The important point here is with this current approach, it will definitely complement the classical DFT calculations as well. Now, what businesses and researchers should do next? So the first thing is they have to first identify one commercially material problem. It could be a battery cathode or electrolytes or catalyst, and then on this system run a classical based DFT approach, identify or establish the DFT based results, and then design quantum algorithms and run quantum algorithms on the similar system, and then definitely compare or validate classical versus quantum results and see what commercial value is they are getting from running these experiments. I'll also be sharing an article index for this discussion where I'll be showing you the topic which we discussed, the algorithms being used in this, what is the maturity of those algorithms, what are the companies being involved in this discussion, and what is the business relevance for this particular discussion which we had just now. Thank you so much. Thanks for listening to this episode of Q4Quantum. If you like this monologue, kindly like, share, and post your comments. Until next time, keep learning, keep building, and keep exploring the future of quantum. Thank you.